Hey guys, Mr. Mackey here. Now yesterday's video we were going into more detail on probability, finding the probability of events occurring if we were to do them multiple times. And the challenge I set you involved the 26 flags I had on top of my bed. I'll show you the clip now of what they looked like. Now in this challenge I asked you to find out the probability that out of 5 times if I put all of those flags in a barrel and I took one out each of those 5 times, what's the probability that 4 of those 5 times I drew a red flag? So, I've already got the information that you needed. There were 26 flags in total, and I've already answered these 3 questions. There are 5 times we're doing it. The probability, the number of times that we're going to win is 21. The probability that we lose is 5, but let's turn this into a fraction because remember, we can't have the whole numbers. So it's 21 over 26 and 5 over 26. So, what is the probability that I win 4 out of those 5 times? So, what you do 21 over 26, all to the power of 4, because I want to win 4 out of those 5 times, and then you multiply it by 5 over 26 to the power of 1, because there's one other event occurring. Now, let's enter this into our calculators. So we do 21 over 26 to the power of 4 multiplied by 5 over 26. Now when you get this, I'm going to do this to 4 decimal places because it's good to get a bit accurate, isn't it? And I got 0.0818. So if I was to draw 5 flags at random of this pot and then I put them back in the pot after each time, the probability that I would draw 4 out of 5 red flags is this. Now we're going to continue on looking at this pyramid, but with another challenge and another method to lay out probability. Let's check it out. So, we're going to go back to this flag pyramid. Now when I look at this flag pyramid, I know that from the previous challenge that 21 of these flags have the colour red in them. I've also found out that 11 of those flags have the colour blue in them. What is the probability that if I drew a flag just once, I will end up with a flag that has both red and blue in its colour? Now this is quite difficult to lay out with just this information, so we're going to need something a bit more complicated. We're going to need a Venn diagram. Venn diagrams are useful because the middle part of the Venn diagram indicates what the 2 conditions both have in common. So this circle represents all the flags that have the colour red in them, and this circle represents all the flags that have the colour blue in them, and the one in the middle represents the flags that have the colours both red and blue in them. Now I made a little mistake. Turns out there weren't 11 blue flags, there are actually 13 blue flags. It's good to keep track because I nearly made that mistake. But obviously if we put 21 in here, 13 there, the total will not make 26. There's 26 flags, that's way over 26. And that's why we have to consider what goes into the middle first. Now what goes into the middle first are how many have both colours. So let's check. We have the United Kingdom, obviously, then France, then Spain, may not be as clear, but there are blue in the Spanish flag, then the USA, then Portugal, again, may not be clear, but there is blue in the Portuguese flag, then the Czech Republic, then Romania, then Slovakia, and then Andorra. See, another mistake. So there's 9 flags with both of them in there. Now, what we do then is we put that number in the middle, and I'm going to put 9 over 26. Why? Because it helps us keep track of how many there's meant to be in total. So, how many goes in the red pot? Well, we know that out of those 21 red flags, 9 of them will go in the middle. So we take that 9 off the 21 because the circle's still there, it's just they're a bit separate. So 21 take away 9 will get us 12. So 12 over 26 goes there. What about the blue flags? Well, there's 13 in total. You take away 9 from that. That will mean that 4 out of 26 go there. So when you add them together, 12, add 9, add 4, you end up with 25 out of 26. Which means that we have one flag missing. What does that flag mean? Well, that is actually the flag of the country that does not match any of these conditions. It's not red, it doesn't have blue in it, and that flag on this board is Latvia. It's got a pinkish purpley colour. And that's going to go outside the Venn diagram, because it can't go inside the Venn diagram, because it doesn't meet any of the conditions needed. So I'm going to put that there, 1 over 26. Now back to the question I set you. What is the probability that I was to draw a flag had both colours in it? Well, does the Venn diagram help us? Yes, because we have put it. That middle part represents the condition we're looking for. So the answer, the probability that if I was to draw a flag from pot, I would draw one with both colours is 9 out of 26. So what about this one? Either 26 flags all in a pot, and I drew 2 out at random. After I drew the first one out, I put the first one back in the pot, and then I drew another one out. What is the probability that when I drew both those flags, they both only had blue in the colour? No red, just blue. Well, what's the probability of that? 4 over 26. So I drew it once, and then I drew it again. So you square them. So what's 4 over 26 times 4 over 26? You enter it into your calculators. And that gives you 4 over 169 to be exact. So the probability that you would draw 2 blue flags in a row is this. The Venn diagram is so helpful once you get your head around it. Let's do one more on flags, then we'll try another example. What about this one? What is the probability that the first flag I drew had both the colours in them, but the second flag I drew had none of the colours in them? So we're going to be looking at 2 different conditions. The first condition, 9 over 26, and we're multiplying that by the second condition, 1 over 26. Multiply them together in your calculator, and you will get 9 over 676, which is 0.133 to 4 decimal places. Very small odds that would happen, but it's not impossible. Now, let's move on to a different example. Now, during this lockdown, me and my mum, we've been watching quite a few films. We've actually written a list, me and my mum, of 10 films each that we want to watch before the lockdown ends. I've written down 10, my mum's written down 10. It just so happens that 3 of the films on that list we both wrote, which is quite bizarre. And then every Saturday, we choose one of those films by rolling a dice and we watch it. It is quite fun, it's quite productive, gives us something to look forward to for the weekends and stuff, because I'm still teaching, my mum's still working, so when we come back, it's nice to have a little bit of relaxation and enjoy some films. I want to represent this information on a Venn diagram to find out the probability of certain films being chosen. So, let's do this. I'm going to draw my circles. And I'm going to put a blue dot over this one representing my films and a red dot over this one representing my mum's films. Now the first thing we need to know is what goes in the middle. What is in the centre of this Venn diagram? Well, there's 3. So I'm going to put 3 in the middle. The second thing we need to consider is how many films in total are we considering here? Well, this is where it gets a bit interesting. 10 of mine, 10 of mum's. So the most likely thing you will go is, well, there's 20 films in total. But 3 of those films are the same. It's almost like I wrote 10 films and I wrote the same thing 3 times. It still means that there's just 7, it means there's just 7 films on that list that are different names. Which means that out of all the films that me and my mum chose, there are 17 films to choose from. So the actual probability is 3 over 17. So what goes in my list? Well, I had 10 films. 3 of them were the same. So what goes in here is 7 over 17. What about my mum's? Well, it's exactly the same. There's 10 in total, take away 3, 7, 17. But remember in the one we did earlier, what goes outside? Does anything go outside? Well, no. Because we're only considering films on mine and my mum's list. Those are the 2 conditions. There's no other film that does not meet this condition that we're using in this little experiment. There will always be a film on my list and there'll always be a film on my mum's list. So the probability that we would choose a film that's on neither of our lists is 0. Almost improbable. But never mind about that. Let's now focus on the Venn diagram. Now, what is the probability that on the Saturday coming up, we'll be choosing a film that I had on my list? Okay? Now, the probability of this happening, people say, well, it's 7 over 17. That is definitely, those are the films you had on your list. But there's more than 7 films that I wanted on my list. We're forgetting the ones in the middle. I did not say in the question, what's the probability that I chose a film that is a film on my list and not on my mum's? These are films that I chose generally. Which means that the actual probability that we choose a film that's on my list is 10 out of 17. What about the probability that we choose a film that's on both our lists? Well, that one, the Venn diagram tells us for us. It's 3 over 17. And then what about the probability that we choose a film that's on my mum's list, but not on my list? Well, that is 7 over 17. It's already given to us. Now, here is your challenge for today. Now, obviously, when we watch a film, we don't put it off on our list again. We cross it off. So what is the probability that the film we watch this Saturday is on my list, but the film we watch next Saturday is just on my mum's list? So we know the probability of the film I'm watching this Saturday, 10 over 17. So what is the probability that that's going to happen, but then the following weekend, it's a film that's just on my mum's list? Let's see how you do. Good luck with these Venn diagrams. We're going to do more of these tomorrow. Have fun. Take care. Good luck.